Here we have 2022 question 8. This Ferris wheel has a diameter of 120. When it's turning, it completes exactly 10 full rotations in 1 hour. 60 minutes divided by 10, 6 minutes for 1 full revolution. So what have we got in here? Pi over 3, 2 pi divided by pi over 3, 2 pi over c is the period, and you can see there that we're going to get the 3 on top and the pi's will cancel. This is equal to 6, just to confirm. So 6 minutes for our 1 full revolution. The diagram above shows the Ferris wheel before it starts to turn. At this stage, point A, the lowest point, is 12 meters above the ground, so the highest point is going to be plus 120, 132 above the ground. The midpoint, 60, will be 72 above the ground. Sorry, 60, 72, yeah, 72 and 60, 132. These 2 points will be 72. And the height h, and we're given this function here, this cos function. So let's fill in the table in part A. So here's our table to fill in. I'm just going to do a little sketch first before we draw this cosine curve. Here we have 12. If it rotates in 6 minutes, we're going to have 6 equal sectors along here. Each of them will be 60 degrees due to the circle. So here's 1, 2. We see here, across the middle, down the middle will be 180. So we can just kind of estimate in here, these are 60 degrees. All of these, 60, 60, 60, slightly off. But let's assume this is after 1 second, or 1 minute, 2 minutes, 3 minutes. It has to be at the top if it takes 6 to go all the way around. 4 minutes, 5 minutes, 6 minutes, back to the bottom at 12 meters high. So do we have any information here? Let's have a look. We'll just fill in some information. 72, the max value of this function is going to be 132. We have that for 3 minutes. 132, 72 plus 60 is 132. That's the max value. We just need to get 1 and 2. They mirror with 4 and 5. So 72 minus, this is h of 1, 72 minus 60 by the cos. If you want to keep it in degrees, pi over 3 is equal to 60. I'll do this question in degrees. So if t is 1, we're just getting 72 minus 60 cos 60. That's giving me 42, which is given actually. I should look at the question first. h of 0 we have as 12. So 5 has to be the same as 1. We said already from our little diagram. So 5 is also 42. So putting 2 in, h of 2 is 72 minus 60 times the cos of 120 when t is 2. And 72 minus 60 cos 120 is 102. And then 4 will be 102. And then 6 will be back to 12. And then 7 will be the same as 1. Minute 7 then, it'll be up to 42, the same as 1. And minute 8 will be up here, which would be, what do we have, 102. So there's the table. What do we ask for then? In part B, the graph. Okay, so we have our points. Let's fill them in slowly. 0, 12. 1 we got to be 42. 2 we got to be 102. 2, 102. 110, so it's like down the bottom, 102. 3 was the max of 132. So 132. Then we're mirroring them off. 4 is going to be back to 102. 5 is going to be 42. We got that in the right place. 40, 50, yeah. 42. 6 will be back to beginning at 12. And then 7 will be back up to 42 again. Just be careful putting your points in. And then 8 back up to the third point up, which was 102. 102. So it's a cosine curve here, so curve it down. Take your time in the exam. I can have a few attempts here at trying to do it. I'm going to go backwards, up, down, and it's kind of curving back at the bottom there. It's not coming up straight. So this is my effort. Part C, find a period and range. Well, the period is 6 minutes. We found that already. The range is from 12 to 132, which we have from above. During a 50-minute period, what's the greatest number of minutes for which point A could be higher than 42? Let's go back to our graph here. When is A higher than 42? Along here. So you kind of see when it's not. It's not higher than 42 during the first minute and between the 5th and 6th minute. So not higher than 42 in here, which is 2 out of the 6 minutes. There are 4 left. 1, 2, 3, 4. So it looks like for 2/3 of the time it could be higher. The greatest number will be 2/3 according to our graph. 2/3 of 50 minutes. That's what they're looking for here. 50-minute period, greatest number of minutes. So 2/3 of 50 is going to be 33.33 minutes. So 33 1/3. So the greatest number of minutes, I think 33 minutes here. It doesn't say greater than or equal to. I think 33 would be correct. Part E. By solving the following equation, find the second time, the second value of t that the point A is at, the height of 110 after it starts turning. Okay, if we go back to our diagram, it's going to be equal to 110. So just go back to my diagram here. At 2, it was at 102, so just here and here, it's 102. They should be equal, you know what I mean? So this is the line of 102. So 110 we're asked for is going to be in here before it gets to 132 at the top, and also in here. So second 1, second 2, it should be between second 2 and 3 the first time, and between second 3 and 4 the second time. So let's have a look. Between second 2 and 3 and between second 3 and 4 is going to be what we'll get here. So we'll bring 60 cos pi over 3 times t to the right, which would mean the 100 would come to the left, giving us 72 minus 110 minus 38. So the cos of pi 3, 60 degrees, times t is equal to minus 19 over 30. 30 minus 19 over 30. So we get the inverse cos of 19 over 30. This should help us here. I think it's the easiest way to look at it. And the inverse cos of 19 over 30, it gives 50.7 degrees. So let's just have a look at our sketch again. I can do it here again, between this point and this point. So we said this was second 2, second 3, and second 4. Second 1 was here. So here's the bottom. So this is 160-degree interval. If we take it like a circle, 160-degree interval going this way. This Ferris wheel goes this direction. Here's my second 60-degree interval. They're all equal. And we can see that our answer is in the third one in here. So 60, 120, between 120 and 180. So we draw when is cos negative in our unit circle. Cos is negative, not in these two, in these two here. So if I draw my angle of 50.7 degrees in here, the actual angle I'm looking for, if that's 50.7, would be 180 minus 50.7, which is 129.3. That's the first time it's going to be in there. And then the second angle, you can see it's going to be the next sector where cos is negative, between 180 up at circle number 3 and number 4, between 180 and 240 will be the next angle. Just do my unit circle a little bit bigger. In here, I want to do my 50.7 degree angle again. The angle is going to be 180 plus 50.7 to give me the same ratio. 180 plus 50.7 is 230.7. So now if I want to solve it, I can say that the cos of an angle, cos of some angle, gives me this ratio. So if we take it from up here, this pi over 3 is 60. So we can say 60t. Initially, the first time will be at 129.3 degrees, and the second time will be at 230.7 degrees. So our two answers will be 3.845 for this one. 3.845. Does that match off what we said between the third and fourth second? You can see it does. And this one here is giving 2 point. We don't need it, but it's giving me 2.155 seconds. And the question asked, give your answer in minutes, correct to 2 decimal places. So they're not saying minutes and seconds. So 3.85 minutes, I think, correct here. And then we're asked to use integration to find the average height. So integration, we're going to integrate h of t, integrating 72 minus 60 cos pi over 3 times t. And it's over the first 8 minutes, so between 8 and 0, and we're looking for average value 1 over b minus a, this one. So we're going to have 1 over 8. If we integrate 72, we get 72t. Cos goes to sine, so it stays as a minus 60 sine pi over 3 times t. And then the differentiated angle will be pi over 3 outside, which will change it from the angle into the number 3.14. So we put our numbers in here. We're going to get 1 over 8 times 72 times 8 minus 60 by the sine. I'll just keep it as 60 degrees. 8 by 60 will be 480 degrees by pi over 3. And then that'll be minus, it's going to be 72 by 0. Well, the sine of 0 is going to go in here, isn't it? So the sine of 0 is equal to 0, so it's actually going to be just 0 minus 0. So we don't need this part. So an 8 of 72/8 or 576 minus 60, this is giving me 54.42. And an 8 of that, an 8 of, well, I'll just do a 521.58 is 65.2 meters for the average height. And if we look at one little small thing before the end of this question, we look at our diagram. Go back to the first one. If we look at the average height, you can see the average height because it's in sixes. The average height over the course of one full turn will be this line in here, 12 and 132 at the top would mean a jump of 60, wouldn't it? So 72, so the average height over the first 6 minutes will be 72. And if you go back in here and you use the integration part and you put 6 in, you will get 72 as the answer down here. So I think a nice little question for Leaving Cert 2022.